Hello guys, so today we are going to solve an interesting problem called egg dropping puzzle. So first I will explain the problem statement in simple terms. So the flow would be like flow of our lemon would be like let's say problem statement, then approaches to solve, then implementation, also we need another one is like insights or intuition. So basically it's like what insights we get from problem statement that helps us to approach to the solution. Third is approaches to solve, fourth is implementation, and fifth is time complexity analysis. Cool. So now for problem statement, you can take some time to read this problem statement yourself. Pause some minutes of your time, pause the video and then read this problem by yourself. Once you are done, unpause it and I will explain in a shorter term. So first it's like you have n eggs and k floors, and there is this f flow which we can say as the critical flow. Any egg dropped from this flow, kf flow, basically any egg dropped above f flow breaks, and any egg dropped at or from or below a flow will survive. And our goal is to minimize the number of worst case attempts needed to find f. And here we have some certain rules we have to follow while trying out the flows. That is, in an egg that survives a fall can be used again. A broken egg must be discarded. The effect of a fall is the same for all eggs. If the egg doesn't break at a certain floor, it will not break at any floor below. If the egg breaks on a certain floor, it will break on any floor above. Cool. Let's explain in a better pictorial way. Okay, so let's say we have a building. And let's say there are multiple floors. My drawing is not that great, so you can please cope up with the drawing. Okay, good. So this is the first floor and this is like the in floor, or as in the question given, there are k floors 1 to k. So let's say this is k floor and this is 1 floor, and let's say this is the critical floor f, critical floor f, this is k question. So when first time I approached this question, I thought like I have to find the F float, and I thought of trying it out using binary search, but I don't need to find the F float. We have to find the minimum number of moves. You need to determine the value of F with certainty. I just explained it because of my purpose, because I missed it. If anyone else had missed, he can also understand that. But that's my takeaway from this question, is that to read the question twice to confirm. Okay, now coming back to the problem, we understood the question, right? So from this problem we get some key insights. One is like, at every move we have two choices. Either we can drop the egg or not drop the egg. Based on, but using, while dropping the egg only, we can find whether it is a critical choice. So this is certain that we have to drop the egg. Now we have a choice that if we drop the egg, two possible situations can happen. Either it can break, or either it cannot break. Basically this is not break, and let's say this is breaks. So based on whether it breaks or not breaks, we either search below, we will search below if it breaks, and we will search above if it doesn't break. This is an important point, so keep a note that based on whether it breaks or doesn't break, search below if breaks. That means basically if we are here any fluid from F to K, basically critical flow to top flow, we need to move down to reach till the critical flow F. Another is, so another option is that we have to search above or up if survives. So in this also we have some additional data points that would update. Is like, if egg breaks, what will happen? We would have fewer eggs, that is one egg is destroyed, so we would have lesser eggs, and fewer flows to compare as well. And if egg survives, same number of eggs but fewer flows. see, these two are kind of a overlapping subproblem, and wherever there is overlapping subproblems and recurring, you can see we have to do recurring, we have to choose recurring operations over each number of floor and eggs. So when these two conditions are met, we need to try out DP, dynamic programming. So this is a kind of a very classic problem for my MCM based dynamic programming. What is MCM based dynamic programming? MCM based dynamic programming is matrix chain multiplication problem. This is one approach. Now how do we understand that whether matrix chain multiplication approach can be used here? So basically we can see here number of eggs and number of floors changes for each floor. Basically for each floor we have to either go above or below, and in our DP recurrence solution, so basically it's like for, let's say, if we traverse the floors using, let's say, a variable I, or let's say k only, so for each eligible k floors we have to try out these two options, which is actually like MCM. In MCM what happens, we are given a number of matrices and we have to find the optimized way to perform the chain multiplications. So in that we have to traverse all the dimensions of the matrix and then check which is the minimum. Similarly for this, we have to traverse all the floors and then find the minimum number of moves you need to determine the value of f with certainty. Okay, so we know now that we have to use MCM. So let's try out first the recursive code of MCM. Recursive code. Let's say this is our function int e comma int k. E is our number of eggs, k is number of floors, So here if it doesn't break, we have to solve for the above flow, which would be current top load minus current flow that I am trying out. Okay, and the answer will be m is equals to math dot minimum of min comma 1 plus math dot max among these two. Breaks comma not breaks. Now why we are doing this and why we are doing this. Math dot minimum is pretty simple, that we have to find the minimum number of moves in minimum number of moves. That's why we are doing math dot minimum. But why max among breaks and not breaks? So we are doing this because we have to traverse all the possible checks we have done to reach the F flow. That can be done using max only. So let's say if breaks gives a value and not breaks a give a value. Let's say someone is at the okay, I will explain the solution once I solve the once I give the base cases. Otherwise making you understand this max part would be pretty much difficult. So what would be the base cases? Base case would be when number of flows is 1 or number of x is 1. So in case let's say number of flows is less than or equal to 1, let's say number of flows is equal to 1, then return 1, because using one egg only we can perform it all. Now if is equal to 1, then return number of flows f. Why f? Because if we have one egg, then what we have to do? We have to try out every single floor. We have to use this egg on first floor, then second floor, third floor, every floor. Because if we try it from the top floor and let's say the floor is here in F, this will break and we will not be able to go down to check which is the critical floor. That's the reason for egg is number of eggs is equal to 1, we have to always return the number of of total flows, as we have to test all the flows starting from first flow to the critical flow, which sums to the total value of total flows. Why total flows? Because worst case would be that the critical flow is K itself. Okay, now why this 1 plus max breaks, command not breaks? Here this one, because we perform the operation. We perform the move. We either went down or either we went up. Basically we either we broke the egg or we didn't broke the egg by throwing the egg from the current floor K. Okay, and now why max of breaks, not breaks? Because of the worst case among these two. We have to find the worst value, the worst number of moves needed to check the below breaks condition and not breaks condition, and from that we have to find the minimum. That's the reason we have to find the max of breaks recurrence call and not breaks recurrence calls. Now once you have understand this, then we can go to the DP, or you can say basically tabulation through memoization solution for this. Let me know if you need more understanding on this. I can explain this approach much better, more in depth as well. So now to solve this using a memoization, it's really simple. What we need to do basically is like we just need to store this in a table. So basically let's say this second is should be called from a main function. So let's say int egg drops, and in that it takes number of eggs as n, and this number of floors. Our DP storage, dynamic program memoization storage, to store the pre-computed results, list of integer DP. DP is equals to new array list Java. We need to do variables. Other approaches are also there. In C++, there is also predefined function. We can also use predefined functions also. So here in Java, new array, dp.add new array list, collection dot 10 copies k plus 1 comma initializing it with -1, return star n comma k comma 2p. So this should change to list of integer dp, and here if dp dot get number of eggs dot get number of floors not equal to -1, then we can consider it's computed. Also, I forgot to add the interpreter for this. This should be return mn. So here, if the result is pre-computed, then return the result, and then we have to save the result also. We will set here dp dot get with index. We will put at the f float what would be the value, computed mn value. This is memoization. Okay, cool. Whatever questions you have, feel free to comment in the videos. I will try to answer it in much better way. If you think there is some other ways we should dive into the problem to make this problem understand more better, please suggest those as well.